and series extension. Can you see
Yes.
that? Yes. Okay, brilliant. All right, so let's go. Sorry about that, but unfortunately, these are the issues we have with load shedding. All right, so in the previous session, we were talking about, cool, Zianda, we were talking about the term formula. So the term formula for a geometric series is this one that I'm now going to highlight in blue. This is the term formula. And the sum formula is the one that I'm now going to highlight in yellow. That's this one over here. This is the sum formula. All right. In the next question, just give me 1 second. Hold on. There we go. Okay, all right, let's get going on this question. In the previous session, we'd spoken about how term 1 is A and term 2 can be written as AR and term 3 can be written as AR squared because, of course, it's AR to the power of n minus 1. That's how we would write any term in a progression or a series. So this question over here is very similar actually to the one that we just did in the previous session. So let's take something that's a little bit more difficult, all right? They've given us this question. The constant ratio of a geometric series is -2.5, all right? So they're telling us that R is equal to -2.5, which if we want to, we can write that as -5/2. The sum of the first 4 terms is 17 2/5. Calculate the first term. So what do they want us to calculate in this case? What answer are they looking for? The value of? The value of A. All right, so when they ask us to calculate the value of the first term, they are in fact asking us to calculate A. Yes, Sianda. Okay. Now we've got to make a decision, all right? What formulae are we going to, because we can calculate A using Tn, and we can calculate A using Sn, can't we? Because if we go and have here and go and have a look, both of them have got an A in them, all right? So what makes this a challenging question for us to answer is knowing which formula we're supposed to be using. Because look, I've got an A there, and I've got an A there. All right, so go back down. The clue is in the language, right? They are saying to us here, all right, the sum of the first 4 terms is 17 2/5. So the implication here is that in order to work out what A is, all right, we need to use the Sn formula. Does that make sense to everybody? Okay, because they have told us that sum to 4 is 17 2/5. So that means that 17 2/5 is A, this is our unknown. R, we know is -5/2 to the power of 4, the sum of the first 4 terms, -1, and this is all over R -1. So -5/2 -1. Okay, does that make sense? So we're not doing it simultaneously here. We just need to work out what A is. They've given us everything else. So now we're going to cross multiply. So what I'm going to do is I'm going to stop here and I'm going to let you guys do the rest of this question. All right, and then we'll talk about what the answer is. All right, so Matrix, see if you can finish this on your own. And when you've done that, then you can pop your answer for A into the chat and we'll see if it's correct. Again, if you've got any questions, don't hesitate to ask either myself or Katlego for assistance. Okay, we're here to help you. Anyone got an answer yet? That's not what I got, Luke. I hope I'm not wrong.
Hey, ma'am.
Yes.
My answer, I think it's the same as yours. I'm gonna look again.
Oh, there we go. So someone's got a similar answer to me. Ziyanda, you've got -5/8. Mine was the other way around. I got -8/5. What did you get? Sorry, who was just talking to me?
Sipo.
Oh, okay. What did you get as an answer?
-5/8.
-5/8.
Yeah. But I'm not quite sure. I don't get it. Yeah.
Okay, that's fine. Let's go through how we would actually calculate this. All right. So is everybody happy about how we subbed into the formula? That bit is okay. So we know why. We know that this is an SN, so we understand that it's gone here. We know we're calculating A. We know what R is. Everything else makes sense. The first thing that we need to do, because remember this is over 1, is we need to cross multiply. Okay, so in other words, we have to say 17 2/5. So remember, when you want to put 17 2/5 in your calculator, you have to press Shift and then the fraction button. So put in 17 2/5 into your calculator. And now you're going to multiply this value. We can put it in brackets. So put the bracket in and then say -5/2 -1 close bracket. And when we multiply those two together, do you guys get -609/10? When I multiply 17 2/5 with -5/2 -1, I get -609/10.
I got the same.
You got the same? Okay, cool. Thanks very much. Right, there is our A. We want to make A the subject of the formula. So if we had a sum like this, if we had an equation and we had that 2A was equal to 8, we would divide both sides by 2 because 2 is the coefficient of A. So this bracket functions as a coefficient. It's the coefficient of a in this question. So that means that a can be calculated by dividing both sides by the square bracket. So that means you've got minus 609 over 10 divided by the square bracket. Okay, so minus 5 over 2 to the power of 4 minus 1. Now you need to put that exactly as is into your calculator. And then let's see what you guys get. Anyone got an answer they can share? There we go. There we go, Lesedi. I get exactly the same answer as you. Okay, so I've ended up with negative 805. How are the rest of you doing, Matrix? Is that making sense? Are you getting the same thing? If you've got any issues on you don't know what to put into the calculator, then ask Katlego and I and we can assist. That's it. That's so good. Good, good, good. Okay, good, Zianda. I'm so pleased. Nice. How's everybody else doing? Are there any questions? Is there anything you'd like me to explain, or can I go on to the next question, Matrix? Oh, how annoying, Peter. Yes.
Can you do me a favor and repeat from let's say from the beginning, because I kind of got this really mixed up. Because my calculator, it gave me the right answer first. Then when I calculated the same way as you did, it gave me the other answer. It was a long digit number. It was so confusing.
Wow.
So I just want to know if I did a mistake or something.
Okay, all right. So tell you what, let's just rub all of that out. Okay. If there's anybody that understands this question exactly, you can have a look at the next example that's on the screen. Okay, so that's this example 3 down here. And you're welcome to sort of start trying to work on that. We're going to go through that question next. But if for anybody else who didn't understand this, let's just go through the steps again. Okay, so that means that sum to 4 is 17 2/5. Okay, it's going to be equal to A in brackets, R in this case is minus 5 over 2. This was sum to 4, so our exponent is 4 minus 1 all over R minus 1. So it's minus 5 over 2 minus 1. That's what's going to go into the denominator. Okay, so our first step is to cross multiply. So we are going to multiply this bracket at the bottom over here with this number. Okay, they're going to be multiplied together. So on your calculator, press Shift, press the fraction button, and you will end up with that. So then you can put the 17 in here, the 2 there, the 5 there, and then you can press times, press bracket, minus 5 over 2 minus 1, because you want that to be calculated first, press equals, and you should get minus 609 over 10. Is that happening? Are you getting that answer?
Yes, ma'am.
Okay, all right. So now you want to make A the subject of the formula. So A is being multiplied by the square bracket. So we need to divide both sides by the square bracket. So when A is on its own, all right, it's going to be minus 609 over 10 divided by my square bracket. Like so. Okay, that gives me A on its own. And if you pop that into your calculator, now you've got to be careful. Press this button. So you press your fraction button. And then what you need to do is move up and put your cursor in the top here. And then you're going to press the fraction button again. And that will give you a fraction in a fraction at the top. Okay, so you can put in, so then it'll do this. So now if this is the big divide line, you've now got a fraction over a fraction. So in here you put the minus 609, over there you put the 10. Then you're going to toggle down to the bottom, and then in here you're going to put your bracket, another bracket, minus 5 over 2, close bracket, to the 4 minus 1, close bracket. If you open two brackets, you must close two brackets, press equals, and you should get minus 8 over 5 as your final answer. Is that working for you now?
Yes, ma'am. Thanks.
Okay, brilliant. It's a pleasure. Okay, so Matrix, we were going to go and have a look at this question next. This is a nice, difficult question. All right, so I hope it's got you excited. Let's read it together and then we can decide how we're going to approach this. All right. The sum of the first four terms of a geometric series is 15. The sum of the first four terms of a geometric series is 15. Now, the next thing says the sum of the next four terms is 240. The question asks us to determine the positive constant ratio. So they've told us the ratio has to be positive, so R has to be greater than 0, and that's what they want from us. They want us to solve R. Okay, so going back and looking at the blue, all right, how would we write the sum of the first four terms of a geometric series is 15? How could I write that?
Ma'am, what are they asking us to determine?
So we have to calculate the positive constant ratio. They've given us just two pieces of information. The information that they've given to us, I have highlighted in blue and orange. All right, so the blue writing says the sum of the first four terms of a geometric series is 15. So that means that the sum to 4 is 15. So in other words, using our SN formula, okay, we can now sub in 15. 15 is SN, is equal to A R to the 4 minus 1 all over R minus 1. Okay. The problem with this, of course, is that we need to solve for A and we need to solve for R. So let's just shelve that for now and go and have a look at the next bit of information. The next bit of information says that the sum of the next four terms is 240. So actually, the sum to 4 is 15. The sum to the next 4, so the next subsequent 4, is 240. So in other words, maybe that's not the best way for me to write it. So in other words, what they are saying to me is that I can calculate the sum to 8, because the sum to 8 is the first 4, which is 15, plus the next 4, which happens to be 240. Does that make sense to everybody? So in fact, the sum to 8 is 255. Are there any questions? Does that make sense? So now what I could do is make another equation. 255 is a, open brackets, r to the power of 8 minus 1 over r minus 1. And that could be equation number 2. Right. So now we're going to have to do some interesting manipulation here. Is that all right for everybody? Is it making sense so far? Okay. I think what I would do now, I'm just going to rub this bit off because I've explained where that comes from. I just want to try something here. So the 15 is equal to the A, and then here you could write that as r squared minus 1, r squared plus 1. And then at the bottom you've got r minus 1. Just want to see if factorizing difference of two squares in this case is going to help us. R minus 1, R plus 1, R squared plus 1, all over R minus 1. So that cancels with that. So in other words, we have 15 is equal to A times R plus 1 times r squared plus 1. Let's just see what we can do over here, if we can do the same thing. Otherwise, we can try cross multiplying. So 255 is equal to A, r to the 8 minus 1 is r to the 4 minus 1, r to the 4 plus 1. Okay, so that's not going to factorize any further. All over r minus 1. So that gives us 255 equals A, r squared minus 1, r squared plus 1, over r to the power of 4 plus 1. Comes very long, doesn't it? I wonder if there's a quicker way for us to be able to do this. And again, we've got r plus 1, r minus 1, r squared plus 1, r to the power of 4 plus 1, over r minus 1, which then leaves us with 255 equals A, r plus 1, r squared plus 1, times r to the power of 4 plus 1. So what we could do is we could divide again. What I'm going to do is I'm going to put the red equation up here at the top. So let me just write it over here and I'll write it a little bit neater. So we've got 255 equals A, r plus 1. Then over here, I'm just going to have to move this over. R squared plus 1 times r to the power of 4 plus 1. And I can divide that by my previous equation, which was, 15 equals A. And this was r plus 1 over r squared plus 1. So now we can cancel out something at the top with something at the bottom. Remember, we can eliminate A because A divided by A is going to leave us with 1. R plus 1 can be divided by R plus 1, and R squared plus 1 can be divided by R squared plus 1. So what we've got is R to the power of 4 plus 1 is equal to 255 divided by 15. So 255 divided by 15 is going to leave us with 17 in this case. All right, so that means that r to the power of 4, take the 1 over to the other side, is 16. And I don't know if you remember this, but not this previous lesson, but on Tuesday's lesson, we had spoken about what would happen if you calculated the value of a number where the root is going to be an even root. So r to the power of 2 or r to the power of 4 or r to the power of 6 is equal to a number. Here I'm going to have to take the fourth root, which means that r is going to be equal to positive or negative 2. But in this case, they told me that r has to be greater than 0. So therefore, r would be equal to 2. How did that go? Was that difficult?
Wait, ma'am, so you have to simplify the two sums before you can divide them?
I would simplify them. So what I've done is, and I don't think this is the only way that you could do this. This is certainly one of the ways that we could do this, is that we've ended up with difference of squares over here. And we've also ended up with difference of squares over here. All right, so that's what I was doing when I was factorizing. I factorized difference of squares, and then I could factorize difference of squares a little bit more. That can't factorize because that's sum of squares. And then I factorized difference of squares just a little bit more. And I ended up with those 4 brackets. And then I could cancel what was at the bottom, the r minus 1, with the r minus 1 at the top. Okay, so that left me with a multiplied by what was left over. So that was r plus 1 times r squared plus 1 times r to the power of 4 plus 1. So essentially, each of those brackets just functions as a coefficient. All right. Then on this side over here, the exponents were a little bit smaller, so it was a little bit easier for me to work with. All right, so r to the power of 4 minus 1 is also difference of 2 squares, and that's going to factorize into r squared minus 1, r squared plus 1. All right, so now if I factorize my difference of squares, I get r plus 1, r minus 1 times r plus 1. I can cancel that bracket over there with that one at the bottom, and then I'm left with this. And then I can divide the one equation by the other. Okay. Does that make sense?
Yes.
Difficult question this, isn't it?
Yes.
Yeah. Are there any questions or comments? Is there anybody that I've lost?
Ma'am, can you make the screen a bit smaller so I can write down everything?
Yes. Let me... I don't know. If I do that and then I move it over to the side, I don't know if I can. I don't know if there's a zoom. Katlego, do you know if there's a zoom here that I can make the screen smaller?
I don't know. Let me try and figure this out.
Okay, so just try and write that down. If you need me to move the screen a little bit more, let's just see. Yeah. What's that? No,
Then you can move it to the side. The side.
Can I move it to the side? Okay, all right, I'll do that for you right now. How's that? So I'll move it to the side and then I'm going to move it a little bit down.
Thank you, ma'am.
No problem.
Thank you, ma'am.
No problem. There we go. Katlego's helped me and I've just managed to find it. Okay. So I've kind of zoomed out a little bit now, but everything else is obviously going to be quite small. So after doing that incredibly difficult question, hopefully you are feeling pumped like Kakeho over here, and you want to try one of these difficult questions on your own. All right, so there's question number 8, which is the easiest. Then there's question number 10, which is sort of a medium type question. And then the question at the end, question 1, has got a red traffic light next to it because that is the most difficult question. So we've got 20 minutes. So I think it would be nice if we could try and do at least 2 of these. Are you guys okay to try these on your own? Or would you prefer me to take a question and do it with you? What would you prefer, Matrix?
Ma'am?
Yes, Sinisipho.
I prefer that you take question 8 and try it out with us.
All right, that's fine. No problem. I'll do that with pleasure. Okay, so let's grab question 8 and let's go down here. And let's move all of that stuff up. Okay, there we go. So let's do this together. All right. So it says to us, determine the first 3 terms of each of the following geometric sequences. All right. So in other words, what they want from us is the first 3 terms. So in other words, term 1 is A, term 2 is AR, term 3 is AR squared. So like in the previous lesson, they're not telling us to calculate A and R, but that's what they mean. That's what they're implying, right? So what information have they given us? Okay, so the first thing that they've told us, let's highlight that, is that the 6th term is 28. How do I write the 6th term of a geometric series? AR to the power of?
5.
Good. So AR to the power of 5. The 6th term of a series is 28. What did I say we should do with the 11th term, the one that's the higher power? We should write that at the... Can anyone remember from the previous lesson?
At the top.
At the top. Absolutely. So now I want to write the next bit of my equation, which is the 11th term is 896. So how should I write the 11th term? The tricks? AR to the power of?
10.
10. Excellent. Is 896. So because I am working with 2 geometric sequences or 2 geometric equations rather, I cannot eliminate by subtracting. I have to eliminate by
Dividing.
By dividing. Good. Okay, so A divided by A is 1. I've eliminated the A. And when I divide R to the power of 10 by R to the power of 5, I keep the base and I subtract the exponents. Now I need to do the same thing with the numbers on the right. So I need to calculate the value of 896 divided by 28. Right, that gives me exactly. And now what do I need to do with 32? How do they want me to write 32?
Power of 5.
Beautiful, 2 to the power of 5. Okay, equals R to the power of 5. And now that we have made the exponents the same, can you see our exponents are the same? Now we can equate the bases. So therefore R is equal to 2. To 2. Okay, we're equating. So we've equated the exponents so that we can equate the bases. Are we finished though? No, because the question didn't say calculate R, the constant ratio. The question said calculate the first 3 terms. So now that we have R, we need to go and calculate
A.
Hey, good. All right, so again, it's your choice. I would work with the equation at the bottom rather than the one at the top, simply because it's smaller numbers. So A is what we want to calculate. In place of R, we're going to put the 2 to the power of 5 equals 28. So 2 to the power of 5 is the coefficient of 32. Sorry, the coefficient of A, which is 32. So 32A equals 28. So that means that A is 28 over 32, except that we can't leave an even number over another even number. We need to simplify. So in its simplest form, this gives us, that's it, lovely, good job. Okay, that one was a bit easier than the example that we did, hey?
Mm.
Does that make sense, Matrix?
Yes, yes.
Okay, so that's one of the sort of slightly easier problem-solving questions. If you'd like, I'm happy to do another sort of particularly, well, not particularly, but another difficult one with you.
Can
Yes,
you do 10?
Katlego? Can I do 10? With,
Lee,
yes.
I just wanted to ask, since they specifically said determine the first 3 terms, would you not have to go back and say T1?
Oh, yes, yes, of course you would. Sorry. Quite right. Thank you, Katlego. Okay, so Katlego is quite right. I started off saying that, and then for some reason I didn't do it. Okay, so that means that, let's just finish it off, and then we'll do 10. Term 1 is 7 over 8. Term 2 is going to be, what are you guys getting? Are you getting 7 over 4? Yes?
Yes, 7 over 4.
Okay, all right, okay. And then the third term is, I get 7 over 2.
7 over.
That's
Yes.
it. Okay, good job. Okay, nice one, Matrix. So let's go back and do another difficult question. Let's go and grab number 10 here, and I'll just move it down to the bottom as well. And then you've got nice space to write in. Okay, let's move that down. Okie dokie. So now, they tell us that a sequence is geometric. They tell us that term 3 is 15 over 16. They tell us that term 6 is 5 over 18. And the last term in this particular sequence is 40 over 729. Find the number of terms in the sequence. So in other words, what letter do they want us to solve for? When it says find the number of terms, they're implying we need to solve for
TN.
for Tn, for N. Okay, so they mean solve for N. Yes, Siande. Yes, Khotatso. Okay, so find the number of terms means calculate N. All right, so now, how are we going to write term 3? So going back here, looking at term 3, how am I going to write term 3? As AR
Squared.
excellent equals 15 over 16. How am I going to write term 6?
AR to the power of 5.
Beautiful. Is equal to 5 over 18. How am I going to solve these two simultaneously?
Divide.
Divide. Beautiful. I'm going to divide. Okay, so A divided by A means the A is gone. R to the power of 5 divided by R to the power of 2. Keep the base, subtract the exponents. And now I need to do the same thing with the numbers. So I'm going to say 5 over 18. And I'm going to divide that by 15 over 16.
18 over 27.
Yes, I get the same answer. I also get 8 over 27. And now we're going to take the cube root. Okay, the cube root on both sides, which means that r is equal to
2 over 3.
Beautiful. Good job.
Ma'am,
Now
you
they
kind of
said-
lost me.
No problem. How did I lose you? Explain
How
where
did
it
you
was.
get
Go back.
2 over 3?
Okay, so you're going to take the cube root, not the square root, the cube root. Okay, so in other words, on your calculator, whoopsie daisy, on your calculator, you were doing this. Yeah? And that will give you 2 over 3.
Oh, okay. Thank you, ma'am.
So the cube root. Okay, so because this is a cube, we have to do the opposite, which is to take the cube root on both sides. Okay, and that's where we get our 2 over 3 from. You okay with that?
Yes, ma'am.
Okay, lovely. Now, remember they said we need to find the number of terms. Okay, so if we use the TN formula to find the number of terms, AR to the N minus 1, okay, what does this number, we're going to go back to the question now, but I just want to establish something first. What does this number represent? Is it an SN or is it a TN?
It's a SN.
It's not a SN. So this is the hard part for us in matric, okay? The last term is 40 over 729. So they are implying that 40 over 729 is a TN. It's not an SN. So if we now want to work out what N is, what else is missing? We've got R, haven't we? We know that R is 2 over 3. We can't calculate N and A in the same equation. So what's missing, guys? The A. So if we want to calculate N, we need to know what A is. That's right, Kotatso and Zianda. I need to know what A is. So now going back here where I was busy on the left. All right, I can't stop there. I can't just work out R. I also need A. So subbing into one of my equations. So A R squared is 15 over 16. Okay, so now I'm just going to go down a little bit. So this gives me square the numerator, square the denominator. A is equal to 15 over 16. And now there's two different ways that you can solve this. Either you can divide both sides by 4 over 9, or if you want to do the reciprocal, which is something we spoke about in our previous lesson, you can multiply both sides by 9 over 4. All right, so that'll also do the trick. Okay, and that'll give us A on its own. All right, so once we multiply 15 over 16 by 9 over 4, or we divide 15 over 16 by 4 over 9, it's the same thing. What do we get as an answer?
135 over 64.
135 over 64. And we would think, we're getting an answer like that, we would think that we were wrong, wouldn't we? I mean, it just
Yes.
seems like such an odd number to have. But in fact, we are 100% correct. Okay, good job. And what are we going to do with our 135 over 64? We're going to sub it in over here. Okay, so we've got 40 over 729 is equal to A is 135 over 64 times r, which was 2 over 3 to the n minus 1. Okay. What's the next step now, Matrix? What do I need to do to both sides? Anybody know? What am I going to do to both sides? Let's see what's in the chat. Divide. Indeed, Khotad. So I've got to divide both sides by 135 over 64. Now, I have a problem. At the best of times, I'm completely blind. I'm sitting here in the dark and I can't see anything on my calculator. Katleho, you're going to have to help me here, please.
No problem, Lee.
All right, thank you. So on your calculator, will you please say 40 over 729 divided by 135 over 64? And can you please tell me what you get?
I get 512 over 19683. Yes.
Awesome. Okay, is equal to 2 over 3 to the n minus 1. And of course, if we got this massive fraction over here, Matrix, we would also think we're definitely wrong, but we're not. We're not. So we've got to get used to the idea that in Matric, we are sometimes working with some really weird fractions. Okay, it happens in sequences and series. It's going to happen later on in calculus. We are not wrong. All right. Now, this is where our shift fact can help us again. So, but you can't press 512 over 19,683 and then go shift fact. Your calculator won't like that. So you have to do the numbers separately. So if you press 512 equals, then the 512 will pitch up on the button. You press shift fact, and that gives us 2 to the power of
9.
Indeed. Now get rid of that and press 19683. All right, then press the equals button, shift fact, and this gives us 3 to the power of
9.
Exactly. All right, and that's what we want, okay? Because we want to be able to write the left-hand side as 2 over 3 to the same power, which is 9 in this case, equals 2 over 3 to the 9, to the n minus 1 on the right-hand side. Okay, we're nearly there. So if n minus 1 is 9, take the 1 over to the other side, and n will be equal to 10. All right, so there are 10 terms in this sequence. So that's yet another different problem-solving kind of question. So I'll give you a couple of minutes to be able to write that down. Let's just make it a little bit smaller. Is that better? Now you can see everything on one page. Okay, so are there any questions, Matrix? Questions, comments? No. Okay. All right. Perfect. So now, remember we had said in the other lesson, there was also going to be a little quiz at the end of this lesson. So I encourage you all to log out and log back in and try the quiz as well, just to see how it's going. These questions are like the ones we've done in this lesson. It's supposed to be something that's a little bit more challenging. So go and give it a try and just see how you do. Okay, and if you've got questions, we can talk about it the next time as well. Okay, so best of luck. Go off and go and do that now in the last 5 minutes that we have. And we will see you guys again next Tuesday. Wonderful. Thank you so much, Matrix. Take care.